We're looking at vectors now, and a vector is any quantity that has both magnitude and direction. A vector can be represented geometrically, which is our focus for today, as a directed line segment. So that kind of comes out looking like a line segment with an arrow on one end. The magnitude of the vector, v, is denoted by this notation right here. It's two vertical bars on either side of the name of the vector. And that's represented by the length of the vector geometrically there. So to find that magnitude, we can actually use Pythagorean theorem. Another word for the magnitude is norm. So if they ask you for the norm of the vector, that's what they're looking for also. Okay, so a little terminology here. This right here is our vector. This vector is going upward and toward the left. It looks like the angle that it makes with the horizontal right here is maybe about 35 degrees. It is directed, so there's an arrow on this end which says that it's from the tail to the head. The tail is also sometimes called the initial point, and the head is called the terminal point. And then we can also write this in component form. So for the component form, you would say, well, how far to the left or right does it go? And that would be your first piece of the component. And how far up or down does it go? And that would be your second piece of the component form. And then the notation for that component form are these little arrows. So this notation denotes that what's inside is a vector and not just a point or whatever else you might see. Another thing that I really need to emphasize is that the direction matters. So that means how much slope you have on your vector matters, and also which way the arrow is pointing on that vector matters. So all of that is important with these vectors. If you have that incorrect, then your vector is wrong. Alrighty, so we're going to start off with a few little examples here. We're going to be finding the magnitude of vector v, and they tell me vector v for this first one is negative 512. So I'm going to draw a quick little representation of that. This component form, negative 512, tells me that I'm starting somewhere. I can start anywhere for these vectors. Let me get a line tool for this. So I can start anywhere. And then from there, I'm supposed to go 5 to the left because the x component is negative. And I'm supposed to go 12 up because the y component is positive. So if I draw that in, this would be the direction on my vector there. And then I'm going to need a little bit of information here in order to find the norm of this vector, which would be the length. Maybe I should label that vector. There we go. This is vector v. All right, so I'm going to add in a few other little pieces of helpful information here. So I know that I went 5 this direction, and I went 12 this direction in order to create this vector. So if I draw it like that, you can see pretty clearly that we are dealing with a right triangle type of thing here. So we can use Pythagorean theorem in order to find the magnitude or the length of that vector. Now, hopefully you recognize that we are dealing with a Pythagorean triple here, but if you don't, you could just take the square root of the x side squared plus the y side squared, and I'll go ahead and show that. So negative 5 squared, of course, is a positive 25. 12 squared is 144. 25 plus 144 is 169. And then that's still inside a radical there. So, of course, we do have to take the square root. So the square root of 169 is 13, which means the magnitude of vector v is 13. Once again, this notation here means the magnitude or the length of that vector. Okay, for our second one here, I have the wrong letter there. That's supposed to be a W. Oops. Alrighty, so if vector W is 4, -2, and they want us to find the magnitude of vector W, we're going to handle it the same way. So I'm going to start by drawing a geometric representation of that vector. I think I'll do this one in purple. Got to get all my pens in purple, otherwise things are going to be weird. There, that one. Okay, so here we go. So I'm going to start anywhere. The x component this time is 4, +4, so I'm going to go to the right 4. I'm just going to go as far as I think 4 is. And then the y component is -2, so that means once I go to the right 4, then I have to go down 2. So I'll go down as much as I think is 2. And that means this vector would be going to the right and down, so it's kind of sloping downward here. Now, once again, in order to find the norm or the magnitude of this vector, I'm going to draw in those little pieces of the component that I used in order to draw this vector. So this is vector W. There we go. Okay, so I went 4 to the right, so this is 4, and I went 2 down, so the side was -2. So once again, that does form a right triangle for me. And so to find the missing side, I could use Pythagorean theorem. Now, 4 and 2 for the legs of a right triangle is not a Pythagorean triple. So this time I most definitely have to use Pythagorean theorem. So I'm going to say square root of 4 squared plus -2 squared. 4 squared is 16. -2 squared is 4. 16 plus 4, of course, is 20. And then the square root of 20 can be simplified because 20 has a factor that is a perfect square. So 20 can be rewritten as 4 times 5. Of course, there are other ways to make 20, but I want to use 4 times 5 because 4 is a perfect square. So then I could split it up and say square root of 4 times square root of 5. And then the square root of 4 is 2. So that would be 2 without a radical. And the square root of 5 is not a nice pretty number, so that one's going to stay inside the radical, square root of 5. All right, so now there are a few questions on the Google form for you to answer to practice this skill.